National Electrical Code, specifically the 2008 National Electrical Code, introduced an amendment pertaining to the color coding of non-metallic sheath cable, often referred to as NM cable. This amendment became effective in 2011 and aimed to standardize the identification of NM cable based on its wire gauge. The standardized color codes are as follows. Firstly, white or gray is designated for 14 American wire gauge. Secondly, yellow indicates 12 American wire gauge. And thirdly, orange is used for 10 American wire gauge. Prior to the 2008 National Electrical Code, NM cable was permitted to have a blue outer sheath for 10 American wire gauge conductors. This means that the observation of a blue 10 American wire gauge NM cable in an older dwelling suggests that the cable was likely installed before the 2008 National Electrical Code amendment took effect. It is important to understand that the color coding of NM cable is solely for identification purposes and does not influence or alter the electrical characteristics of the cable itself. The electrical properties such as voltage rating, ampacity, and insulation type are determined by the cable's construction and materials, not its color. When encountering electrical installations, especially in older buildings, it's essential to be aware of the code changes and practices that were in place at the time of installation. The National Electrical Code is updated regularly, typically every 3 years, to reflect advancements in technology, safety standards, and best practices in the electrical industry. These updates can impact various aspects of electrical work, including wiring methods, grounding requirements, overcurrent protection, and equipment installation. The color coding of NM cable is just one example of how the National Electrical Code evolves to improve safety and clarity in electrical systems. By adhering to the standardized color codes, electricians and inspectors can quickly identify the gauge of NM cable, which is crucial for ensuring proper circuit sizing and overcurrent protection. For instance, using a 14 American wire gauge cable on a 20 amp circuit could lead to overheating and potentially a fire hazard. Similarly, using a 12 American wire gauge cable on a 30 amp circuit would violate the National Electrical Code and pose a safety risk. The correct sizing of conductors is essential for safe and reliable electrical installations. The National Electrical Code provides tables and guidelines for determining the appropriate conductor size based on the circuit's ampacity, the type of load being served, and the ambient temperature. These tables take into account factors such as the conductor's insulation type, the number of conductors in a raceway or cable, and the presence of other heat-generating equipment. In addition to conductor sizing, the National Electrical Code also specifies requirements for overcurrent protection devices such as circuit breakers and fuses. These devices are designed to protect conductors and equipment from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip or blur, interrupting the flow of electricity and preventing damage or injury. The National Electrical Code mandates that overcurrent protection devices be sized appropriately for the conductors they protect. This means that the ampacity rating of the overcurrent protection device should not exceed the ampacity of the conductor. For example, a 14 American wire gauge conductor with a typical ampacity of 15 amps should be protected by a 15 amp circuit breaker or fuse. It is also important to note that the National Electrical Code provides specific requirements for grounding and bonding electrical systems. Grounding is the process of connecting the electrical system to the earth, which provides a low impedance path for fault currents. Bonding is the process of connecting all metal parts of the electrical system together, which helps to equalize voltage potentials and reduce the risk of electric shock. The National Electrical Code specifies the types of grounding and bonding conductors that must be used, as well as the methods for connecting them. Proper grounding and bonding are essential for ensuring the safety of electrical systems and preventing electrical hazards. In summary, the color coding of NM cable is a helpful tool for identifying conductor sizes, but it's just one aspect of the National Electrical Code. A thorough understanding of the National Electrical Code is essential for anyone involved in electrical work, whether it's designing, installing, inspecting, or maintaining electrical systems. The National Electrical Code is a complex and comprehensive document that covers a wide range of topics, from wiring methods to equipment installation to safety requirements. It is important to stay up to date on the latest edition of the National Electrical Code and to consult with qualified electrical professionals when necessary. The National Electrical Code serves as the cornerstone of electrical safety in the United States, providing a standardized set of rules and guidelines to minimize the risk of electrical hazards. It is developed and maintained by the National Fire Protection Association, a non-profit organization dedicated to reducing death, injury, and property loss due to fire, electrical, and related hazards. The National Electrical Code is updated every 3 years through a consensus-based process that involves input from a wide range of stakeholders, including electrical contractors, engineers, inspectors, manufacturers, and consumers. This ensures that the National Electrical Code reflects the latest advancements in technology and the best practices in the electrical industry. Compliance with the National Electrical Code is typically mandated by state and local jurisdictions, which adopt the National Electrical Code as part of their building codes. This means that electrical installations must be performed in accordance with the National Electrical Code in order to pass inspection and obtain a certificate of occupancy. The National Electrical Code covers a wide range of topics related to electrical safety, including wiring methods, grounding and bonding, overcurrent protection, equipment installation, and special occupancies. It also includes requirements for specific types of electrical equipment such as lighting fixtures, appliances, and motors. One of the key principles of the National Electrical Code is to protect people and property from electrical hazards such as electric shock, fire, and explosions. To achieve this, the National Electrical Code sets minimum safety standards for electrical installations and equipment. These standards are based on scientific research, industry best practices, and the collective experience of electrical professionals. The National Electrical Code is not a design manual, but it does provide guidance on how to design and install electrical systems in a safe and reliable manner. It is important to note that the National Electrical Code is not a substitute for professional judgment and expertise. Electrical professionals must use their knowledge and experience to apply the National Electrical Code to specific situations and to ensure that electrical installations are safe and compliant. In addition to the National Electrical Code, there are other codes and standards that may apply to electrical installations, such as the National Electrical Safety Code, which covers electrical transmission and distribution systems, and the International Building Code, which covers the structural and fire safety aspects of buildings. It is important to be aware of all applicable codes and standards and to ensure that electrical installations comply with all requirements. The National Electrical Code is a living document that is constantly evolving to meet the changing needs of the electrical industry. As new technologies and materials emerge, the National Electrical Code is updated to reflect these changes and to ensure that electrical installations remain safe and reliable. Staying up to date on the latest edition of the National Electrical Code is essential for electrical professionals and anyone else involved in electrical work. There are many resources available to help people learn about the National Electrical Code, including training courses, seminars, and online resources. The National Fire Protection Association also publishes a variety of National Electrical Code-related materials such as handbooks, guides, and training videos. By investing in education and training, electrical professionals can ensure that they have the knowledge and skills necessary to perform safe and compliant electrical installations. The National Electrical Code is a critical component of electrical safety in the United States. By following the National Electrical Code, electrical professionals can help to protect people and property from electrical hazards and to ensure that electrical systems are safe and reliable. Remember that the presence of blue 10 American wire gauge NM cable likely indicates an installation prior to the 2008 National Electrical Code update, and while not inherently unsafe if properly installed and maintained, it is a visual cue to exercise caution and verify the system's compliance with the codes in effect at the time of its installation. Always consult with a qualified electrician for any electrical work or inspections.